Welcome to the conversation. I am Carrie Ann, and I will be your host in this first segment. With me, I have our Jared, our resident astronomer. Love it. I also have Mike, our rocket specialist. Behind us, of course, we have a Donna who will be producing the show. And because this is going to be our last show of this particular orbit, we will be joined a little bit later on by Benjamin and Tim Dodd, the everyday astronaut, which is also very, very exciting. But before we get into all of that, a little heads up on what's going on in news, Jared.
Yeah, we now know how old or young Saturn's rings actually are.
Mike?
And President Trump formally directs NASA to send humans back to the moon.
Very, very cool. So excited. And then, of course, at the very end, we take a look at your comments and questions about last Orbit's show. Was that right? Last week's show? Anyway, we're going to go with that. This is tomorrow, Orbit 10.46.
Good morning. How's everything up in the sky?
As somebody in the chat room said, they said, wow, 46. Yeah, this is going to be our last show for this particular orbit. Thank you so much for joining us for any and all shows that you've joined us on. And I want to make sure I give a special thank you to all of our top tier supporters. These are the Escape Velocity variety. These people get their name in the show more so than once. They get a very special thank you, of course, at the top of the show. We appreciate every single one of you. And if you guys are interested in getting your name in the show and actually a whole lot of other things as well, you can always feel free to head on over to tomorrow, TMRO.TV. So, goodness, 46, you guys.
46.
You know,
We made it.
I know. I actually forgot to double check to see if this has been the most shows per orbit or not.
Ben is checking.
Ben in the other room is checking for us, so that's great. I will waste some time until we figure out what that is. But I know it's a lot, and I just really appreciate all the work that you guys put into these sorts of things. Every last one of you, even Miss Kitty, who doesn't like to be on camera. I appreciate all of your hard work and effort into these shows every single week. So at least just for me, thank you guys for being here and helping, and you guys too, of course, for helping make this happen. Because without you guys, it just wouldn't be a thing. Okay, so for sure, we want to make sure that we go over some launches, and by golly, were there some launches since last show. So we're going to make Mike tap dance a little bit, and then we're going to give him a little leeway. He's not going to have as many news items because this is a lot. So Mike, why don't you go ahead and hit me, as you like to do, as always, in chronological order of the launches that we've had in this last week. Ready, go.
Yeah, okay, so the first launch was actually on Sunday, December 10th, and this was a Chinese-built communications satellite that was being launched for Algeria, and it was launched on a Long March 3B rocket from the Xichang Space Center in northwest China.
Very cool.
You're absolutely right. It's southwest China, forgive me. But when it was launching from there, the payload is Alcomsat-1, which is going to be providing satellite TV, broadband internet, remote education, and emergency communication services in Algeria once the satellite reaches its planned geostationary orbit in a few weeks. Now, the Long March 3B rocket successfully placed Alcomsat-1 into a geostationary transfer orbit, while the thrusters on board the satellite itself will propel and adjust the spacecraft's orbit for its final destination. Now, interestingly, I did want to mention that China has built similar communication satellites under contracts to other governments. For example, they've built satellites for Nigeria, Venezuela, Pakistan, Bolivia, Belarus, Laos, and they have a couple of more contracts for that in the future. So I thought it was really interesting that they've been able to help provide those type of services, I mean, of course, for a fee for those countries. So very cool, and this was a successful launch, and I'm happy to see that. There might be one or two more Chinese launches before toward the end of the year, but we'll have to cover that on our next show at the beginning of the next orbit.
Yeah, that will be really exciting. I'm not sure how we're going to do that because it'll be Mike talking for like half an hour, and it'll be like, okay, well, there was the launch update show because I'm not sure we're gonna have anything
And
else.
this is your launch space pod.
Yeah, I mean between.
Maybe we can share something
Right,
like that. We'll figure it
that and like Electron, and there's going to be a whole lot of exciting things between now and the next time that we are with you guys all together. So that should be
Yeah.
interesting. But not to waste any more time, there was at least one more launch. Go ahead, Mike.
Yeah, there's a couple more launches. So the next one that I wanted to talk about in chronological order, and I'm actually not sure if this one happened first or if the next one I'm talking about happened first, and you'll see what I mean in a minute.
No problem.
What I want to talk about right now is an Ariane space launch, the last Ariane space launch of this year, 2017, and it was an Ariane 5 rocket carrying 4 more Galileo navigation satellites for the European constellation of navigation satellites.
Nice.
Now, this particular launch occurred on Tuesday, December 12th at 1836 Coordinated Universal Time from the Guiana Space Center in Kourou, French Guiana. And with this launch, with those satellites, there's going to be 24 Galileo satellites in orbit, 18 of which will be operational.
Top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo Falcon 7.
Woo, rumble in the jungle.
Totally.
The solid rocket boosters, the core stage, and the upper stage of this Ariane 5 rocket performed as planned to deliver the Galileo satellites into their medium Earth orbit, or MEO, at an altitude of around 23,000 kilometers, or about 14,000 miles above Earth. And the flight lasted almost 4 hours from the launch to the final payload insertion. Now, the 4 satellites were released in pairs, about 20 minutes apart, and they used their own small thrusters to climb into a slightly higher orbit, about 300 kilometers or 200 miles above their drop-off point. The Galileo payloads were intentionally released into that lower orbit and then used their thrusters to climb into a higher altitude so that they avoid the upper stage of the Ariane 5 and that those upper stages keep their distance from the rest of the satellite fleet. Now, 4 more Galileo satellites will be launched next summer to officially complete the constellation, but as many as 12 more satellites could be launched in the future on multiple launches of the yet-to-be-built Ariane 6 rocket. And something else that's really cool with this is they are now going to be completely compatible and interchangeable with the GPS systems so that there can be worldwide coverage, and not just Europeans, but people worldwide will be able to use both of those services. So very cool to see this, and I always love those Ariane 5 launches and the footage that they have for that.
Totally. I think we talked about this last episode or maybe an episode before that ago, talking about how, they had the graphics right at the very beginning. And so, so you see a picture of the fairy and then you're like, haha, and this is like X-ray vision. This is what's going on the inside. Like, okay, cool. Now I have a better understanding of what's going on. I appreciate that. And if you're not going to get, real camera views of, satellites deploying or anything along those lines, I think it's nice to have all of that, all of those animations. So then there's just a better concept all the way around, I think. Very cool.
Yeah, totally. I wish everybody did that.
Yeah, right? Exactly. I see, because I didn't actually look at your rundown, but now I see why you say what you said. And while this isn't exactly a launch, it's more of a test flight. I can totally see why you put it in this particular section of the rundown. So go ahead, Mike. I don't want to steal any more of your thunder.
Yeah. And what she's referring to is that there's another launch that also happened on Tuesday, December 12th, but I'm not sure exactly what time that launch occurred yet. We're talking about. I mean, it wasn't even officially announced until after the fact.
That's
and of course,
totally
we're
fair.
Talking about Blue Origin. Yeah. So Blue Origin, founded by Jeff Bezos, the owner of Amazon, conducted a surprise launch of their new Shepard rocket with a new Crew Capsule 2.0, which featured some very, very large windows. And this happened at their West Texas launch site. And as we said, it wasn't even announced until way after the fact, almost later that evening, that the launch had even taken place. But in any case, it boosted the new Crew Capsule 2.0 with large windows into suborbital space. Well, almost. Check this out. Now, this launch was the first of the upgraded booster of the New Shepard rocket. It's a New Shepard rocket after the last booster was retired after 5 successful launches and landings. Now, with this, the crew capsule was released after the booster's engine shut down, soaring to an altitude of about 322,000 feet, or 61 miles, which is just about to the Kármán line, which is at 62 miles, or 330,000 feet. So this flight just about made it, although it doesn't quite matter because if you look closely at the image there, you can see particles floating around, and it did clearly have a few minutes of weightlessness on this flight. Now, the booster steered itself back to a rocket-powered touchdown successfully, and this was Blue Origin's 7th New Shepard flight overall, and the 6th success in a row. The last flight was over a year ago in October of 2016 during the in-flight abort test, which was pretty impressive. But even this landing itself was very impressive, and gladly this new vehicle was able to perform as expected. And I really liked how we were getting those views of the inside of the capsule that had the test passenger lovingly named Mannequin Skywalker. Oh, man. But the capsule also had 12 commercial research, education payloads on board that they've been doing on a lot of their test flights in the future. So just seeing this from the inside, there was a much longer video of the inside of the capsule from the mannequin's point of view, and it seemed like a very nice ride. Even coming down and even that landing itself, I mean, using the retro rockets on there, that they sometimes can use that for the in-flight abort test, makes this a very nice ride. I'm certainly ready to fly, and I definitely want to fly on this vehicle one day. So very cool to see this launch from Blue Origin, and hopefully we see a lot more in the future too.
Totally. It's funny that the slightly different perspective I have, or takeaway I have from the video from outside of New Shepard versus inside of that landing specifically. Because from the outside, I'm like, holy crap, like, I thought they were slowing this thing down, man. Like, what is happening? But then you see from the inside, and it's just sort of like a go. Like, it's not that, it doesn't look like it's that big of a deal. And I'm sure there's impact built into the seat and all that other fun stuff. But yeah, I from the outside, it's so flippin' dusty down there that like any sort of wind creates this gigantic cloud, and it looks like you're, gonna break your back.
And that cloud, too, isn't from the capsule slamming down so hard that it creates that cloud of debris. It's from a rocket firing at just the last second to slow it down just a little bit more so that it has that nice cocoon, that won't be too bad to be able to land. So that's what that huge cloud of debris is just a little retro rocket firing for just a second to slow it down for that final little bit before touchdown. So
totally. It's just, it's funny. And it was nice to be able to compare and contrast those two visuals, because it was sort of like, dude, that sound looks terrible, and then, oh, actually, that doesn't look so bad, so I guess that's okay.
Yeah.
There's all that.
That doesn't look too bad at all.
And I suppose there was at least one more launch that happened, so I guess I'll let you take away on that one.
We have another launch and landing to talk about. And of course, we're talking about a SpaceX flight that happened yesterday on Friday, December 15th. This was their 45th Falcon 9 flight ever. Oh, wow. And for this one, they were setting up a Dragon cargo vehicle headed to the International Space Station filled with supplies and experiments. And it's designated CRS-13.
7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. So here, post-launch flight operations. Towers
Love the roar there. Now, this particular launch occurred at 15:36 Coordinated Universal Time from Space Launch Complex 40 in Cape Canaveral, Florida. The first mission from this particular launch pad, since the pad was disabled from the explosion last year during that test firing of the Amos 6 satellite. Now, this was also the first time that the Dragon capsule has been launched on a reflown booster. The first stage of the Falcon 9 had previously flown and landed on the CRS-11 cargo mission in June of this year. And after the first stage separated and conducted its boost back maneuver, which was beautifully captured on camera. Oh man, look at that. The second stage was able to continue and raise the Dragon capsule to its eventual low Earth orbit of about 400 kilometers or 250 miles up. Now, the Dragon capsule itself was also previously flown to the space station on the CRS-6 mission back in April of 2015. So this was just a whole bunch of reusing hardware on this particular flight. But the Falcon 9 was able to, the first stage was able to successfully steer itself and land back on Earth at Landing Zone 1, not far from Space Launch Complex 40. And it's the second time that this particular rocket has done so. And this was also the first time that NASA was able to allow them to do this, flying the Dragon capsule on board of a reflown booster, and pretty much said that it was basically the same amount of risk as if it was a brand new booster that had been built from scratch. So just so awesome to see another success like this. But in any case, the Dragon capsule was able to successfully, was placed into orbit and carries about 4,861 pounds or 2,205 kilograms of supplies and experiments inside the Dragon capsule. And in this cargo bay, it even has some NASA-sponsored experiments that'll be attached to the outside of the space station using the space station's robotic arm. And these experiments are going to monitor the sun's energy output, and another one is going to measure the density and distribution of space junk around the space station's orbit. So I feel like, especially that one, I'm going to be very interested in those type of results, make sure we can mitigate all those micrometeorite debris. But the Dragon is expected to rendezvous with the station tomorrow on Sunday, and it's going to stay at the station until mid-January before returning to Earth with research specimens. So congratulations to SpaceX and everyone who made this launch happen, and we may or may not see 2 more Falcon 9 launches before the end of this year, but again, we'll have to talk about that on the next Orbit show. So so happy to see all these launches this week.
Yeah, very, very cool. Thank you, Mike. I appreciate that. And actually, there was some footage. I didn't get a chance to see the proper webcast yesterday, so there was some of that was, in fact, quite stunning. That was beautiful.
Yeah, beautiful footage. Good job to the people who are responsible for that.
Yeah, that's, Jared, actually, you had mentioned, like, why can't we get some of those Steadicam operators over at Vandenberg that are over at Kennedy Space Center, Cape area?
Yeah. Someone on Twitter said, well, at least you get, they said to me on Twitter, the reason they're not there is because they don't want to get close-up footage of fog. So, and I corrected them, loud fog.
This is true. Very loud fog.
Yeah.
That's funny. Yeah, some those people who are over there are really very, very talented.
They're on it.
All right, so Mr. Jared, now is the time where you dance.
Yes.
You've got some news about Kepler?
Yeah.
What's going on?
So the Kepler Space Telescope, we're still getting data from it. So we're still sifting through a lot of that data too, because it's a lot of data. But what's really cool is that Google actually developed a machine learning algorithm with NASA to actually look at archived Kepler data to see if they can find planets that we may have actually missed looking at it. And they ended up finding 2 additional planets that we actually missed in the data with that machine learning algorithm.
That's cool.
Which is so cool. And these are the first planets to be discovered by artificial intelligence, if you will. So
do they get really cool names then? Instead of like the stupid names we always give planets?
No,
Why
they
not?
don't.
Why doesn't the AI get to name the planets?
The AI should name the planets,
Yes.
just like that AI that started naming paint colors. It's going to work really well.
Think it would.
So Google trained this machine learning network by having it analyze 15,000 previously confirmed exoplanet signals, and then it was given 760 of Kepler's weakest signals to dive in for a data crunch beyond what a human can do, and it had a false positive rate of about 1 in 10,000, so that's pretty good. Now, what's so cool about this is that finding that additional planet at the Kepler 90 system brings the total number of planets in its system up to 8. And in addition to that, they follow this solar system, or this system, exoplanet system, if you will, outside of our own, follows a very similar structure to our own solar system, which is that the lower mass planets, which are more dense, are closer to their star, while the high mass, low density planets are further away from their star. So hey, confirmation that some form of planetary formation is actually kind of universal.
I was going to say, like, that sounds familiar.
Yeah, it does. Well, that's important.
Okay, good.
That tells us that our ideas about formation of solar systems are, for now, correct.
Cool.
until we find the eventual curveball in the
right.
haystack.
I can appreciate that
with
for what that's worth.
Now, this is a great graphic just showing you how the relative sizes of the planets in the system. This is not their scaled distances whatsoever. They're not actually that
They're not
close.
equidistant like that?
No, they're not equidistant
Oh, that's
like
weird.
that. Same with our own solar system at the bottom right there, too. So now Google and NASA's Ames Research Center, which is where Kepler is based out of, they're going to be releasing the code and the training model for the machine learning network publicly. So anyone who wants to conduct their own study actually can and can use the system that NASA used. So super cool result using machines.
Is that the only thing it studies? Like, can it study like A Tale of Two Cities and tell me what the hell's supposed to be going on there?
Maybe.
Okay.
That's a different AI.
All right, just
Yeah,
double
that's
checking.
That's a different kind of machine learning.
Okay, that's
so I assume. So
perfect.
But hey,
Yeah.
at least our solar system might not be so weird after all.
yeah,
Yes.
it turns out it's actually normal. So go figure.
Go us, I guess.
Now relax, everybody.
I know. All right, Mr. Mike, you do have a little bit more talking to do. As I know
Okay.
you don't like to get too political, and yet you keep bringing up political stories, which makes me laugh.
Yeah, well, and with this story too, I mean, despite how I feel and how maybe a lot of people feel about the politics surrounding the administration, I feel very positive about this, and a lot of people seem to be very positive about this too. What we're talking about is the Space Policy Directive #1, the first official formal policy directive from the Trump administration to NASA, and it was just a really brief ceremony at the White House on Monday, December 11th, where Trump signed the order to officially send human astronauts back to the surface of the moon as a near-term goal on the way to Mars. And this was done at the signing ceremony, literally the first space policy that Trump has ever signed. And Apollo astronaut Harrison Schmitt was there from Apollo 17, as well as Buzz Aldrin from Apollo 11. Peggy Whitson was there, and lots of other space officials that are part of the National Space Council. And this was officially endorsing recommendations that the National Space Council had made to President Trump. But you know what? Let's just hear it straight from the horse's mouth.
Finally, we're honored to be joined by Apollo astronaut Jack Schmitt. Exactly 45 years ago, almost to the minute, Jack became one of the last Americans to land on the moon. Today, we pledge that he will not be the last, and I suspect we'll be finding other places to land in addition to the moon. What do you think, Jack? Where's Jack? What do you think, Jack? We'll find some other places out there? There are a couple of other places, right?
Here's the important part.
The directive I'm signing today will refocus America's space program on human exploration and discovery. It marks an important step in returning American astronauts to the moon for the first time since 1972 for long-term exploration and use. This time, we will not only plant our flag and leave our footprint, we will establish a foundation for an eventual mission to Mars and perhaps someday to many worlds beyond.
So yeah, that's basically it. Not a whole lot of info, but the implications could be huge, or huge, however you want to say it. And
You got Ben Credible to
like I
laugh
was
at
saying,
that one.
despite how people feel, despite how people feel about the politics behind this, I mean, this directive means that NASA is supposed to be working towards this near-term goal of sending humans back to the moon and setting up some sort of base or habitat for future use. And already there's a lot of really cool ideas and responses to this that are very positive. There's been lots of commercial ideas through the years, especially going back to the Constellation program, and some of the big companies are ready to take this on. I mean, there's lots of lunar plans that could continue, and the Deep Space Gateway could even fit into this whole architecture and enable lunar lander missions to the surface of the moon, and even, sending cargo and setting up habitats if we do plan on having some sort of permanent base on the moon for a little while, whatever its capacity may be. So yeah, with that, I mean, I'm really excited about this, and even though the details are vague, the companies and organizations who are positive about this directive are already putting their plans forward. Boeing has been re-pushing their plans for their own lunar lander. Northrop Grumman was the contractor for the Altair lander, so I'm hopeful that they will get something going again to potentially do this, and I'm really hopeful that whatever way that this moves forward, that it will be done under some sort of fixed price, milestone-based program where there would be lots of competition, and we'd be able to do the best program forward like we have done with the commercial cargo and commercial crew programs. So I'm really excited about this. My only complaint is that this directive does formally abandon the asteroid redirect mission, which is something that I feel is absolutely necessary for our survival. But, I mean, if anything really does pose a risk to us in the near future, I'm sure that NASA and the other space agencies of the world would be able to get it together and ensure that nothing bad like that would be able to happen. Asteroids, nature's way of asking how your space program's going.
So, Space Mike, I got a question for you. Did they talk about additional funding to actually make this happen?
Nope, no funding at all, nothing like that. It's just the directives that this is what NASA is supposed to do. And even within NASA, I mean, the acting administrator Lightfoot is very positive about this. And just from the little bit that I've seen so far, it seems like that this could be a very doable thing, although it seems like that more of the focus is going to be on the deep space gateway, at least in the near term, especially because of our international partners who are expressing a lot of interest in it. JAXA has been putting forward a lot of really cool plans to add modules to it. Canada has already been putting forward plans for Canadarm3 to be used on it. The Planetary Society has a really cool idea for a light sail for it. Roscosmos has 3 different modules that they've been proposing for it. So it seems more and more likely that the Deep Space Gateway is going to happen in some sort of capacity, and combined with all the different commercial plans like ULA and Bigelow Aerospace's Cislunar 1000 plan. That's not funded, but, well, the studies are funded.
Look, no bucks, Rogers. I know that
$200 million that's invested in the Deep Space Gateway right now in the Next Step program to study all the different habitats that could be built with Thales Alenia Space, Boeing, Lockheed Martin to build the Deep Space Gateway. So this is something moving forward, even though it's not officially on the books. But I personally feel that it's still going to happen.
hang on.
This show is called Tomorrow. And so we have a positive outlook on what is happening tomorrow. And if we have learned anything in the last, 10 orbits or so, it's that when commercial companies get some sort of really tight deadline that everyone goes, that's not possible. Well, you can't land rockets. That's an impossibility. We have companies who are landing rockets. So if you have an impossible deadline and you just don't think you can do it, hopes and wishes all of a sudden magically appear and make things happen.
But not without funding. That's the critical thing here.
That's amazing. I have a whole rest of the show to go through.
But this is important. This is important because this could be. We've heard and seen this time and time again.
It doesn't mean that it can't happen.
It doesn't mean it can't happen. But without funding, this means nothing. This is just all talk at this point.
Allow me to say this. Allow me to say this for a moment. The people who are going to be responsible for the funding of this are the same people who recommended this in the first place.
But until that happens, this is Constellation 2.0.
It's just a matter of time. It's just a matter of time.
I don't know. Once they fund it, I will change my tune.
Continuing resolution.
Well, look,
what makes you think that they don't have enough money to do it now?
They don't.
How do you know that?
Because we can't even get SLS off the ground. Understand, what we're talking about here is Constellation 2.0, right?
I would say it's even beyond Constellation 2.0. The executive branch has been proposing big dreams since Bush won in 1989, and nothing's really come of it
fail after
since.
fail after fail. This is exactly what we've seen for every single presidency, and I am all about an optimistic view of the future.
Yes.
Fool me once, shame on you. Fool me twice, shame on me. 3, 4, 5, 6 times.
Actually, you know what? Vax makes a really excellent point.
Who does?
Vax.
Yeah,
right, that's correct.
Which is true.
Which is actually, again, to the point. Not funded. It doesn't matter whether the president funded it or not. President can go, we're going to go to the moon and set up a base, and then we're going to go to Mars. If he doesn't get the funding from Congress to make that happen, it's not going to happen. So these are all really neat ideas. I do hope they happen. I think they're really great. But I don't see any of it's all talk. I don't see any of the stuff necessary to actually make this happen. I absolutely hope I'm wrong. But it's everything that we've seen and heard for decades now. So that's the end of my little rant. I think it's very important, but I also think it's important to set expectations.
Technically, I'm the one with the soapbox. So are you done?
I'm done.
Great. Jared.
Hi.
We like Saturn so much we put a ring on it.
Oh, nice.
But apparently, we've only liked it for a little while.
Yeah, it turns out there's an interesting result that has come out of Cassini that they talked about at the Oh boy, I'm crashing and burning right now.
No.
AGU. So
You're totally fine. As far as Ben's concerned, this probably means that Saturn just farted and then now has a cloud around it. And he's laughing, so he knows.
There you go.
I
for those
still
of you,
love him, I promise.
For those of you counting the fart jokes at home, that was number 1.
Yes.
So the first person who actually observed Saturn's rings was Galileo about 400 years ago. And since then, their structure and origin has kind of been a bit of a mystery to us here on Earth. And it's taken sending a probe there to physically understand them. And that is Cassini, which did 22 very brave dives between the rings and the upper atmosphere of Saturn earlier this year. It was studying those rings closer than we've ever seen them. So, are those rings actually old or are they young? Well, if the rings were old, say leftovers from the formation of Saturn 4.6 billion years ago, we'd expect exposure to things like solar and cosmic radiation to darken that ice and rock and that makes up those rings. But several scientists have argued that the density of the rings would prevent this from happening. Well, data from Doppler experiments using tracking systems to precisely determine the position of Cassini have shown us that the rings are only 80% the mass that we expected. That means their density is deceptively less than we thought. So this is actually in line with data that was collected in the 1980s by the 2 Voyager spacecraft on their flybys, but it required flying between the atmosphere of Saturn and the rings, so that way we could isolate the rings' gravitational pull and measure that, and that's what Cassini did earlier this year to provide that definitive evidence. In addition, an instrument on board at Cassini called the Cosmic Dust Analyzer actually registered what was basically a rain of dust and micrometeoroid particles at Saturn. So this means that those should significantly darken Saturn's ring material in, bear with me here, a astronomically short amount of time, as in like a billion years. So Saturn's rings, they're young. We don't know exactly how young, but we have a range somewhere between 150 to 300 million years old. So that tells us that these might actually come from a moon that just got too close. Saturn's gravity ripped it apart and actually ended up forming that, or 2 moons close to Saturn collided, and that's the debris left over from it. So now we get to debate, was it a moon getting ripped apart or was it moons colliding that made those rings? Because now we know they're young, so now we can start to look at these models and figure out how to form the rings.
Is it like Saturn looking at all of its moons and it's like,
Yeah.
I'm not afraid to break you up and make you a debris
I
field.
must break you. So, right. So,
You two stop fighting back there. I swear I will turn this truck around.
Another
Like that
cool,
kind of thing?
another cool result. I'm just going to throw this in real
Yeah.
quick. Saturn's ring is not a bunch of little separate rings going around. It's actually one big spiral going in. So
Interesting.
isn't that cool? So yeah.
So not separated lanes.
Nope, not separated lanes.
Sometimes
It's
you look
one
at some of those
big
pictures.
thing that's spiraling in. So and it's so cool. So so there you go.
That is
So-
incredibly cool. All right, I know we started late, and news definitely went a little bit late. So if it's okay, I'm going to skip that last one.
Yeah,
Jared.
that last one. Yeah, you could go for it.
Perfect.
So-
Debate, go. Yeah, goodness gracious. We've had a moment. In any case, so what we're going to do next is we're going to take a little bit of a calendar break, and when we come back, we're going to, I guess, debate. I'm not really sure. We're going to go over Orbit 10 in its entirety, all of us together. Stay with us. There's more tomorrow coming up next.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back to Tomorrow. And before we get started with 2017 in review, I did want to give a thank you to all the citizens of Tomorrow who helped to make this specific segment of this episode happen. These people have contributed $10 or more to this specific episode. We also have our Orbital subscribers. These are people who, that's hard to change my verbiage
Yep.
after doing it for a full
So
year
I'm
like that.
asking you to do it.
These are people who contributed $5 or more to this specific episode. To find out how you can help crowdfund the shows of Tomorrow, head on over to tmro.tv. All right, yeah, that was a bit of a, in that last calendar break, Electron rocket said that it was going to be launching this year. They changed. We got a tweet early this morning after the calendar had already been built. They will not be launching in 2017. They're moving their flight to 2018.
Better safe than sorry.
Yeah,
Always.
absolutely. Yeah. So, well, they don't have go fever, right? So that's actually a good thing.
No, what they have is birds.
They do. They had so many birds on that webcast. It was kind of beautiful.
Well, Kennedy Space Center has alligators. SpaceX has cows.
Oh, good call.
Rocket
Oh,
Lab has
cows! Yeah,
birds.
cows!
So-
Yeah, absolutely. All right, so
Spider.
let's get. Oh, by the way, also welcoming Tim Dodd, the everyday astronaut, back into the show for our year-end recap. Yeah. thanks, Tim Dodd, the everyday astronaut.
So good.
So I wanted to get everyone together for the last episode in Orbit 10 before we begin Orbit 11 in early January to talk a little bit about our favorite moments from 2017. And, despite me being pessimistic, I'm normally not pessimistic about these things, but, every president since basically Reagan.
I'm going to lock the door next time on the newsroom.
Every president since Reagan has promised us that we're going back to the moon or we're going to Mars or we're going into an asteroid. Doesn't matter if they're Democrat or Republican. Every president made that promise and never has it happened.
The nice thing is that, A, it can still happen then.
Oh, yeah.
B, other companies can surprise you because they can look at that and say, well, I don't know, NASA's got a directive, so I guess we should really go and do it then. And then C, what's it matter as long as somebody does it?
No, that's the thing. As long someone has to do it, and I'm not convinced it's going to happen. I hope I'm wrong. I don't want to be pessimistic on this. I want these things to happen. I just, I've been burned so many times by being hopeful on this that it's just like, eh.
Yeah,
I've heard all these words before, again and again and again.
Yeah, this
I
is.
say that to you all the time.
Yeah, I know.
This is the kind of thing that I don't have a problem being proven wrong on.
Oh, yeah, absolutely.
I would love to be proven wrong.
Please
about
let me be wrong.
Yes.
Absolutely.
I would
absolutely.
love to be wrong, but history has shown.
You're not wrong.
No,
No.
probably not.
No, I'm not holding my breath on this one. All right. So,
One thing that I do find interesting about this, though, is that, we saved a lot of the hardware, or at least adjusted a lot of the hardware from the Constellation program, keeping around the Orion capsule and the Space Launch System, even though it was redesigned with new engines and everything like that. So there's a lot of that hardware that was originally for going back to the moon that is still around and hopefully will be flying someday. And I don't know, at least for this administration, if that's what's going to be the focus, even if the next administration completely derails and changes focus once again, at least things will move forward in a little bit of ways and something will happen, even if it's not the grand goal that they expect, but something will move forward. And that's,
Really?
I at least have hope in that.
I mean, you're allowed to have hope in that, and I commend you for it, but really? I mean, look at the Space Launch System versus Ares 5. We still don't have a flying anything. And Constellation had Ares 1 and Ares 5 and Altair and Orion, and then it got whittled down to basically just Ares 5, which we renamed to the Space Launch System.
Altair,
we can't even fly that.
I mean, technically, Altair wasn't even actually funded. Like there were studies done for it, but there was
Just
no
studies, yeah. It's the
no
engineering
actual
studies.
hardware bent.
All right,
to
we
make it.
spent way
So,
too much time
yeah.
on this pessimistic thing.
Oh,
This
you
is
mean
not
that thing that you started?
I'm getting yelled at.
I think we figured out our first roundtable of 2018. So
Oh man! All right,
Hashtag
all right.
not saying, just saying.
All right. So let's start with 2017 because we did have a really absolutely incredible year. There was pessimism aside. There are incredible, amazing things happening before our very eyes, right here, right now. And I'll start with you, Carrie Ann.
I knew you were going to do that, and I don't want you to, but go ahead.
All right, I'll start with you, Jared.
No, it's fine. Here's the problem. Here's the problem, and I don't mean this in a bad way, but you're right. So many amazing things have
It's hard to
happened.
pick.
I don't remember all of them, and I'm going to miss something, and I don't want to miss something, which is really, really
Well,
terrible.
you don't have to miss anything, but was there something that stood out to you? Something where you're like, yeah.
You mean where you were wrong and I was right and everyone acknowledged that? That happened at least once this year. Not saying.
Probably.
Okay, perfect. I like that year over year since we have started this show. Again, Orbit 10, right? So thank you, Corkspin. year over year, it's like, oh, but this thing's really getting started. Oh, things are really happening. Oh, wait till next year, just the next 6 months. No, really, but really. That we keep feeling like things are really moving, things are really happening, and I hate the phrase now more than ever, but really now more than ever, it really does feel like there have been so many really amazing, wonderful, awesome, just even barely off of the ground things that have happened and are happening that I am apt to forget something, and I think that that's really fantastic. I think that's my favorite, in a weird way, that is my favorite part of it. Between, again, I'm going to miss somebody or something, ISRO coming online, and I can say ISRO and people actually understand what I'm talking about. I don't have to go into like, oh, well, did you know that India has a space agency? JAXA is doing, ESA is doing, what all of the different kinds of Mars simulation things that are going on here down on Earth in various ways. It's some that are crowdfunded, some that are sponsored by different agencies. Everybody who's left the ground, or at least is trying to leave the ground, right? Like this is a test with Electron, but Blue Origin is doing amazing things. Virgin Galactic's doing amazing things. Even Virgin Orbit is really doing some interesting things. There's just so many different things, and it's great. It's not just like, oh, have you heard of that one company? I remember when we started talking about SpaceX back in the day, and nobody had even heard of SpaceX, let alone we had to explain space exploration technologies and all those sorts of things. That you can continue to say these names and sort of throw them out even casually, and it still means something to somebody, or at least it's starting to a certain extent. And I think overall that's my favorite. I know it's a slightly cop-out answer, but at the same time, I think that's really fantastic.
I think it's a really good answer. Just basically saying this was a year of a lot of things coming online. Maybe not one big moment, but a series of small moments that added up to one.
And everyone can kind of have their favorite thing. I like the medium launcher. I like the large launcher. I like the small launchers. I like the things that aren't even launching. I like the things that are trying to land. I like the things that have landed. I like the things that are about to be landing. Like, all of those, when you, right? I mean, those,
There's a lot.
There's a lot. There's moon landing and Mars landing and roving and you name it. There's just a lot of everything. It's not just like, man, we got to seek out that one other story from that one other company that's not NASA.
There's like a niche for everybody to find.
Yes.
If there's something for everyone, depending upon where you want to go with it.
Yeah.
So
whether it's satellite or military or government or crowdfunded or pick a language. Somebody's got something in that language that's happening right now that are involved. GLXP. I'm going to take up the whole rest of the segment. You understand what I'm saying? That's my favorite. Go on.
Well, yeah, we'll move it over to. No, I think it's a really great answer. I think that was a really great answer. And Jared, you favorite moments of 20. We're going in rows, right? So you guys get ready with yours because I'm going to go to Everyday Astronaut and then the hologram.
Do I have to pick one?
No, you don't. You don't. But if you're going to pick more than one, then we need to kind of understand why.
I am going to pick more than one because so much happened in astronomy this year. It was just in astrophysics and things like that were just amazing. And then there's one that personally for me I really want to talk about as well. So obviously the end of the Cassini mission, probably one of the most productive planetary missions ever. Cassini started when I was in elementary school. That's how long the mission had been going on for. And wrapping it up, and probably one of the most flawless missions as well. And the things that Cassini showed us at Saturn, not just the beauty of Saturn and the rings itself, it was also the fact that there were other worlds with these moons around Saturn as well. Titan, one of the largest moons in the solar system. It's got a hydrological cycle. It's not like the water cycle here on Earth. It's methane. How weird is that? Like there's liquid methane on the surface. Like actually there's lakes bigger than the Great Lakes here on Earth of just methane and hydrocarbons and other things like that. And that was amazing. And Cassini showed us Enceladus, which Europa was always sort of the shoe-in for. This is where life probably is, and it's going to be really difficult to actually get in there and see it. And then Enceladus comes up. It's like, hey, I've got even better conditions than Europa, and you could find it right at the surface. So it's almost like, come back. Come back to me. Hey, how's it going? I'm here. And I got habitability. There's maybe some hot dogs on here, you know? Like,
Made of methane.
yes, this is made of methane. If you're really big on silicon and hydrogen, we can get it for you nice and cold so you can have a good drink. You know, that kind of, it's this place. We have to go back to Saturn now. Before we went to Saturn, we were not expecting all of this to be there, and Cassini revealed all of this to us and lifted that veil and showed us that even in our own solar system, at one planet, there can be multiple places where a habitable area could actually possibly be. And then, the interstellar asteroid coming through, Oumuamua, that is something that we have talked about for a very long time, as in this should be happening very frequently, and finally getting to see not just detect an interstellar asteroid coming through our solar system, but actually getting like spectra so we can figure out what it's made out of, what its shape is, what color it is, trying to characterize it, and finding out as much about it as we can. Unfortunately, we didn't catch it coming in, which is a bummer because it would have been cool to have actually gotten a mission to intercept it and get a really good look at it. But it's still really cool that we now have the technology to actually detect these kinds of objects that are coming into our solar system. And I know a lot.
You went to the eclipse this year too.
I was going to get to that.
Okay,
so that will be my final one that I get to.
Oh, I'm surprised that's your final one. The chat room actually had right.
Oh,
so
yeah, we were being
Mika,
yelled at. I'm sorry.
so-
I took away your thunder. Go, keep going.
I also want to talk about gravitational wave 17.
Oh, there we go. I knew it was going to come up. Sorry. So gravitational
So-
waves. We got Kay McCoy said gravitational waves. Then we got Ming Lord said gravitational
Because it makes
waves.
such amazing. They make such good noises.
Rebel kind of said gravitational waves, but with a bunch of other stuff as well.
Gravitational waves are so hot right now.
They're so hot right now.
And I would specifically want to highlight gravitational waves, not because it won the Nobel Prize. It did, and that was basically.
Let me just throw that in there. It did.
So when it was announced back in February 2016 that they had detected a gravitational wave, it was literally basically there were two things in the scientific community that were said about that. One, amazing, we got it, we confirmed it, relativity still works, black holes are real, things like that. The second thing was basically that's winning the Nobel Prize. Like, good luck, who's ever competing next year. You are not going to win it.
Right.
That's going to win it, and it did, because that's how big of a discovery it was. And then this year rolls around, and we get gravitational wave 170817, which is
Just rolls right off the tongue,
Yes,
Jared.
it does.
Thanks. Yeah, that's great.
Well, what should we call it then? I don't know.
I don't know, but
gravitational
really
waves.
seriously, we should let the AI
Frederick.
name these things. The scientific community does suck at these.
Sure.
I mean, we could have Princess Ivory or Lyndon Green or
Actually, I do like Space Kyle's response, which is "Stop all science now. It's over. We're done."
I also like Stargoon. That's a good one.
That's a pretty
Light
good
of
one.
Blast.
Sandan.
Sandan.
Yeah, that's not bad.
All right, I'm sorry.
Stanky Jane. Turdly. Anyways, so gravitational wave 170817 was so important because it was a neutron star merger, and that meant that it made an optical counterpart. So when black holes merge, there is no matter interaction that is energetic enough to actually send out light in wavelengths.
So you're saying it doesn't matter?
So it does matter. It's just that the matter don't.
Zinger.
The matter not. I screwed that one up. But when two neutron stars collide, that is like the densest form of matter that you can have in the universe. So that's a tremendous amount of energy being released, and we saw it. We saw the light from that. We saw it in multiple wavelengths, and we measured it. And the amazing thing about that is not necessarily that we detected it, because we expected detections like that to occur. It's when we looked at it and we saw the nucleosynthesis, the actual building of heavy elements occurring. Things like gold, platinum and other heavy elements, that it wasn't exactly clear where these were made. There were models that said that neutron stars colliding would cause this, but that's a model that hadn't actually been seen in nature. And then we looked right at it, and it lined up perfectly with the models. Just
Well, that's what science should
excellent.
do. Science
So-
should be able to predict the future, right?
Yeah, that's
you should
what-
be,
that's
you should
what
be able
it
to
is.
model it, and if it's
So-
correct, then that model should occur in the future.
But it's very rare. It's very rare in science for your model to line up perfectly with nature. Usually, nature's got you need to tweak a couple things and then it explains it. No, not in
Nature's
this
like,
case.
"Ah."
It was just exactly. It was perfect. It fit. Exactly. It was like that last. It's like that. You're making a big jigsaw puzzle, and there's a piece right in the middle, and you've been thinking about it for like years. How's that? What piece is going to fit? And then you finally pick one up, and it goes straight in, and it was like that. And that was amazing. There's a lot of people who are saying that discovery will also be up potentially for Nobel Prize winning kind of thing. And that would be amazing for a single instrument to end up doing 2 Nobel Prizes out of it for 2 completely different things. And then I guess to cap it off, to end it with the eclipse here in the United States. The first eclipse to only be visible in the United States in 99 years.
Mika agreed. The eclipse.
Yeah, I that's who I was with. Mika reached out to me after my original person I was going to stay with in Oregon didn't work out, and we made it happen. We went to it. We drove a Tesla Model X, probably where it should never go, and.
I didn't know you were in an X.
Just that experience of it. There's a couple coworkers up at Griffith who have seen eclipses before, and they're always like, "Yeah, I can't describe it to you. You just got to go there and you got to see it." And I was like, "That's so cliched. Like that's just a bunch of crap." Like you.
Great, and now you're going to tell me
that.
that you can't describe it and you need to go see it.
It is very. I can try to describe it, but it would be very difficult for me to actually get you to feel the exact same feelings that I did during the eclipse.
It's interesting that during an eclipse, you look at kind of nature and just the animals around, and they all kind of freak out as well.
I freaked out.
Yeah.
As soon as totality came in, this little buzzer went off in my head, and it went, "Something is wrong. Get out of here immediately." It was like, oh my gosh, the sun is gone. Like it's gone. It's not here. It is gone. Where did it go? Kind of that really low level on your brain with that there. And to see just so many people coming together to take a look at it and experience that all together, that's really what brought it home to me, which is that when we went back into Salem for lunch, that was the only thing anyone was ever talking about at the restaurant that we stopped at for lunch. That was the only thing people could talk about, and it was. It changed me very profoundly, and I sort of it definitely reaffirmed a lot of my enjoyment of nature and things like that.
You need the overview effect in addition, right? So that seems like the next natural step.
I feel like that would be. I mean, I'm not going to say no to riding on a rocket.
Blue Origin.
So call me up, Jeff.
We need a ticket.
Call me up, Jeff. I give you $79 a year, so I should at least get a rocket. Gosh.
Well, we need 5. What is it? 2, 4, 5. Yeah, we need 5, 6. We need like a pack of 10.
Just if you ever have the opportunity to go see an eclipse, do it. Drop everything. Go to it. You are not going to regret a single minute of it. And my coworkers warned me that once you see an eclipse, you're going to do everything that you can to stand in the shadow of the moon on the earth as much as possible for the rest of your life. And I literally already have my plans for Chile in a couple of years ready to go. So it's true. You will become addicted to it, and you will crave it, and you will need it, and you will want to tell everybody to go see it. And I cannot agree anymore that the gravitational wave and nucleosynthesis would be my top one, but experiencing the eclipse in person was just
is Seek, how do you pronounce that, Carrie Ann?
What, Seki?
Seki.
Said in the chat room, there are people who do this all the time, eclipse chasers. Are you becoming an eclipse chaser?
Yeah, as much as my financial ability will allow me to currently. So
Chris Mara
yeah.
also said it literally looked unreal, and then from YouTube, Lennon said, "I saw the eclipse. It was awesome."
Yeah,
yeah.
You can look at every photo of an eclipse that you want to. There's people that can get close. Fred Espenak is one of the best eclipse photographers in the world, and his absolute best photo is amazing, but it still does not compare to the actual thing. It's just, gosh, it was amazing. So,
All right.
Yeah.
Let's move on. Tim Dodd, the Everyday Astronaut. 2017 for you.
Can't start off without talking about this shirt. This
Oh,
shirt
yeah,
is one of my
look at that. That's amazing.
Pull that up.
2017.
Oh,
Right,
my goodness.
right?
So,
That happened
That's
in
awesome.
2017. So, yeah, 2017 was pretty great.
All right, great.
but-
Thanks, Tim Dodd.
Aw.
That's our show. Thanks for
Got
joining
a shirt.
See ya.
No
man.
one will guess where I'm going with this one. That's a joke. I think number one, the shot of a Falcon 9 with the SpaceX logo going up for the first time on pad 39A at CRS-10. That shot. You know which one I'm talking about.
Iconic.
It's the rockets go, and you just see SpaceX go up. To me, that's like that
I
was
did
one
that.
of my favorite
They
things.
did that once on the first one, and then never again. That was a one-time deal. Also, Shaky says agrees with you. Reactivation of Pad 39A stands out. Yeah.
Yep. And that to me, because it mirrors so much those shots of the Saturn V. You know, the Saturn V had. There's always that shot from the tower of the vehicle going up like that. And we just really didn't have a recent rendition of that in a sense. And to me, it stood for a lot of things. And it sounds super cheesy. And of course, it's like super eye rolly. Of course, Tim's going to say Falcon 9 39A. You know, I mean, yeah, that is. And to top that off, that same launch had one of my favorite, the first of many of my new favorite shots of launches, which is the drone shot of the Falcon 9 when it returns to LZ-1. Oh, that footage is just incredible. It really helps put it into perspective. These daytime return to launch site landings are just incredible. And I think we've had, a 5 or 6 now or something. I lost track already. And I just love those. They're so cool. So that's kind of one mission wrapped into that together for me. But then also, I had to say for me, I think honestly, just knowing that Falcon Heavy is finally like physically a thing is just, I'm so excited.
And that you were right.
Oh yeah,
And
yeah.
then I was right.
You were excited. You were going back to see how far earlier you predicted this payload.
I have to admit, I think that the first evidence I had was me in February saying, please put Teslas inside the payload fairing for the first, for the payload for the first Falcon Heavy launch. And now, not only are they doing that with a Tesla Roadster, but they're sending it to Mars, which to me is just like, I would have been happy if there's just even a model, like a toy model of a Tesla in space. I would have been super stoked. And instead, they're sending a freaking, Generation 1 Roadster to Mars. That's
So
to
crazy.
me, yeah, come on, doesn't get better. So when that happens, that'll top 2018 for me already. Yeah, of course, that's what I'm gonna say. So that's pretty much my 2017 in a nutshell. Oh, besides for me, the Eclipse was great. Eclipse was cool. Jared already totally made that emotional and great, and encompassed all those feelings. But I think for me, I had a similar experience when I got to stand about 3 miles away in the causeway for CRS-12 and watch a booster come back down. And when you're that close and you feel the sonic booms that close to a booster that's falling from the sky, oh my gosh, it's just nuts. I mean, it is insane. And you watch it and it just really makes you, now I understand that feeling that Buzz Aldrin had where, people are denying his experience of being on the moon. And I mean, that's on a 10 million times more scale than what I'm experienced. And when people try to deny me that it's all CGI and stuff, and I'm like, I have seen it and felt it and feared for my life as you see this tower of fire coming down towards you. And then the sonic booms shake you and you watch it happen in front of your eyes. It's an experience that I'll never forget. And I can't wait for it to happen again. I was supposed to be able to catch CRS-13, didn't make that happen. But I can't wait. I'm craving that again. And it's something that the general public can watch with their own eyes. So I think that's pretty game-changing. And I think that's pretty great. Yeah. So that's my 2017.
You know, I would recommend that. One of the I think the easiest way to become a space nerd is to watch a rocket launch in person. There's something that the cameras and the microphones cannot capture. They're so much brighter than you could ever imagine, even during the day. They are so much louder than you could ever imagine. There's just this raw, sheer power that goes into it that I do not know what words to use to describe this. And I personally have never been able to see a rocket land. I don't know when I'm going to be able to do that due to other commitments right now. But I would love to do that as well. And what Tim Dodd explains just sounds incredible. So if you have an opportunity, find a way to get down to Cape Canaveral and watch a rocket launch and land. I just think that's incredible. And Blue Origin will be doing it from the Cape soon, right? Is that correct? Yeah, so then
they're
2020.
in the middle of building their factory that's going to have the New Glenn rockets to launch. They're Canaveral. So
so that will be the place. That seems like it's kind of the centralized place where you'll be able to go watch rockets launch and land, at least for a bit. If you can make it happen, do that, and then head over to Disney World.
And the first landing at Vandenberg is supposed to happen sometime next year. So, and I'm definitely looking forward to being just as close as Tim Dodd was to the landing
being able to hear that through the fog.
Yeah, exactly. So, maybe I could see the fog compress in the shockwave.
That'd be cool. That would actually be a really good, this like shockwave of fog. Like, wow.
Wait, would it be 2 compressions or 3?
Dunn is still angry about that. He's like, I don't understand how it's 3. All right, let's move on. Space Mike, your favorite moments of 2017?
Well, there was a lot of launches this year that I really enjoyed. I mean, of course, all the different SpaceX launches and landings have been phenomenal to see, and probably just the fact that SpaceX has launched more rockets by themselves than any of the other nations or other companies in the world is just amazing. And for the United States, combined with all the United Launch Alliance and Orbital ATK and the other orbital launches, we're able to have 28 orbital launches this year, and we're able to beat China and Russia for number of launches in 1 year. And it's been a long time since America has been in the lead for number of launches in that year, and that mostly is due to SpaceX. But there was quite a few little launches that I found super interesting. There was quite a few Chinese rockets that came online this year that are launching. They're reconverted ICBMs that are launching from pretty much mobile platforms and could be launched anywhere in the world. And there's other types of ideas that are kind of being copied for those type of plans here in the United States, and just the idea that rockets are becoming even more accessible and could be launching from almost anywhere in the world, and seeing some of the different stuff like the reorganization of Sea Launch and some of the funding that's been coming in through the S7 airlines and some of the other Roscosmos money to get that restarted is really exciting for me, that there will be a lot more opportunities and we're not just limited to some of the launch pads that we've been using. But there was probably the thing that stands out in my mind the most is how the quality, and this kind of goes back to what we were talking about on last show, 10.45, where the quality of the webcasts of pretty much most of the webcasts this year have improved dramatically. I mean, even the Chinese launches, even though we're still only getting like a minute and a half of launch footage from them, went from being 360p grainy awfulness to actually being pretty good quality HD footage now. And, it's nice to finally be able to see some detail out of what little bit we do get to see from them. And just, the Ariane space launches, I believe it was this year that they started doing those graphics that me and Carrie Ann love talking about so much, those graphic overlays over the payload. I'm pretty sure they started doing that this year, and I don't really remember before this year the Ariane space webcast launches being so interesting. I can watch the entire thing and be, it sounds weird, but entertained the entire time. And just the quality of what we're seeing and the frequency of what we're seeing is just so impressive. So my favorite moment, I guess, is just the fact that all of these things are happening at once. And even though there's a lot of big projects that a lot of us are looking forward to and that have felt like they've been around the corner for, 10 years plus now, the things that have happened that were a little bit unexpected maybe have been really mind-blowing and eye-opening. And even though we might not necessarily be doing a lot of the space tourism and space might not be accessible to regular people like us in the way that we might want, the things that have happened is opening things up and making the space industry even bigger and making it more visible. And the fact that mainstream media and regular folks, more and more people are getting introduced and being inspired by all of this technological engineering and all of this improvements that we've been doing in space. And despite what, all your flat earth truthers are trying to say about all the stuff being CGI and everything like that, so many more people are being exposed to this and getting excited about it. And I just really love that. And I feel like just the public support for space in general just goes beyond borders, and that the international excitement about what we're going to be doing with our future just gives me a lot of hope, not just for the space industry, but for humanity in general. So it's been a good year.
Yeah, absolutely. I had a follow-up question. I just totally lost it.
Okay.
Neat.
Remember.
Brought this show to a halt. You're welcome, Internet.
What about you, Ben? What's been some of your favorite moments?
Sure, we'll go there. Space Mike, actually, I think you touched on a lot of it, which is just bringing space down to the everyday person. Oh, I know what my follow-up was, which was I agree in that what you said, a lot of news entities are starting to cover these things. And if you look, The Verge has now basically an entire space area. Ours has an entire space area. So these very large online publications, maybe not necessarily mainstream, but I would argue more important than mainstream news because their viewership is so high and fairly specialized.
Would you say is making space commonplace?
Maybe I would say that.
Like 15-minute specials. I'm seeing 15-minute specials about like SpaceX and Lockheed Martin on local news. When local news is dedicating that much time to a space story, you know that things have changed. Oh.
Yeah, absolutely. You're absolutely right. And I think it's really quite awesome that people are taking this so seriously now and are getting engaged and getting excited about going to space. I look at 2017 as one of those foundation years, which, by the way, is something I seem to say every year since the beginning of tomorrow. But I think it might almost be true every year in that we're creating. There isn't like this one element of like, oh, well, now we have enabled space for everyone. This was the year where it happened. It's a series of very small steps that takes a very long time. And we took even more steps in 2017 to making space accessible for everyone. One of the companies I'm most excited about is actually probably Blue Origin. They both make me very excited and very sad at the same time. So I'm very excited about what they're doing. And I think it was actually before 2017. I believe their last webcast was in 2016. And it was, I was on Twitter. I was hashtag Team Booster. It was the abort test. I was blown away at the amount of success. I just figured the booster would be like aerodynamic stresses would rip it apart. Again, I believe that was the end of 2016. I don't think that was 2017. And then I thought, okay, well, Blue Origin will continue to do webcasts now because they've done one. So now they're ramping up and they're getting into it. And they seem to do like one or two. And then this year they went back to, maybe we'll just kind of do a video after the fact, which makes me sad. The space nerd in me and the live video nerd in me was like, aw, I was excited. I want to cheer along.
They did webcast it to. Apparently, they did webcast it to like shareholders or something like that. But we only got to see like a minute and a half of that.
Cool. I guess I need to become a shareholder in Blue Origin then, which I would totally do.
Yeah.
Right? I mean,
let's not forget they also did the Hotfire this year too.
Oh yeah,
their
BE4.
Yeah.
Blue Origin is
the year of methane.
Yeah,
it really is. Everyone's like, let's do methane engines now.
the era of methane is upon us.
Is that the fart joke number 2?
Yeah, number 2.
Just
For
checking.
those counting, number 2. Number 2.
So I'm excited for these next generation companies coming online. And this year, 2017 was the year in which they came online. Blue Origin is flying things. Maybe not people yet, but they are flying things. Electron rocket flew. Right? So we have one flight. It was mostly like wildly successful for a test flight.
Yes.
That was incredible. They almost flew again this year. Not quite, right? Got really close, but early 2018. And then I think once Electron kind of, with any new architecture, it takes a little bit of time to, figure out the weird little things you didn't really anticipate. And then once you get it, you just start stamping them out. I think there's going to be a point where Rocket Labs is just like, neat, we're good to go. It's just like launch, 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 launch. I'm excited for that. I'm not, and that goes back to last week's show of like, okay, well, if Rocket Lab is launching, we'll call it 100 times a year. SpaceX is launching 100 times a year. Blue Origin is launching 100 times a year. When is the point when you just stop webcasting these things? And what a great question to ask. So what?
I said never.
Well,
but that's just me.
Maybe
so.
it is still, even with the smaller rocket, it is still one of the most amazing technological things that humans do. And so I would be willing to. Well, I think
we're going to get to that in comments.
How
Yeah,
great
yeah.
would it be that there are so many launches that there are 24-hour space news networks? Wouldn't that be awesome?
Hopefully that will start here.
Hopefully.
Right? I think that seems like a really great place to kind of move and expand tomorrow into.
Also, I was going to say this year too. There's been a lot of small sat launchers popping up all of a sudden.
It's just like 20. Yeah, it's an insane number.
Yeah, and it's like,
how was it again, Jerry?
It was like like that, It was just all of a sudden, here we are. Oh, by the way, we just mentioned this.
There are even
you're
more.
You're like at the luncheon for a small sat startup, and then another one pops up in the middle of the luncheon. It's like, oh my gosh, it's just all over the place. So.
There are even more coming online that I can't talk about yet, but we're bringing on as interviews in 2018.
Yeah.
So I mean, the amazing things happening in 2017 with the. I think the first step is going to be we'll call it the colonization of cislunar space, that space in between Earth and Luna, the moon. So we're going to start to see a lot more than 6 humans working in space. And that's going to happen over the next 5-10 years, I think. And this was kind of that year that started to enable that. It created the launchers, created the infrastructure, the reusability systems necessary to make that go. With the Bigelow habitat being another one that's going to really start to enable this stuff. And then after that, I think we're going to start to see some of the lunar colonization, not just flags and footprints, but actual colonization. Whether NASA does it or not is up in the air. I think it will be in partnership with NASA, but I'm not sure it will be entirely NASA at this point. I think the industry's changed, and we're going to see a lot of commercial space partnering with NASA to make it happen. But it won't be anything that you've been seeing, like, we're decided to go to... It's none of the announcements you're seeing today. It's not going to look anything like that. It's going to be something totally new and different, but really exciting and cool. And then once that goes, maybe 20, 30 years after that, probably not 20 years, maybe 10 years after that, we'll start to figure out how to get onto Mars as well. So I think we're about 20 years away from Mars. Maybe not. And I'm talking in very broad strokes. No single company. I'm talking like the industry as a whole, right? So a single company may make it there earlier, but the whole industry making it to all these different locations, I think probably 20, 30 years away from that. So that was kind of my favorite of 2017.
We would be remiss if we didn't at least give a little bit of a mention on behalf of Lisa Stojanovsky, Mini Stoj, in the chat room about Australia.
Oh, yes.
Now has a space agency.
Australia has a space. I feel like she
Congrats.
said something earlier I was going to do. There we go. Mini Stoj, IS Space Agency. I forgot. Yeah, they do have a space agency as of late this year. So yeah, absolutely.
What about Dutta?
There was one other cool thing that I did want to mention this that I really liked this year, and that was the Iranian launch of their Simorgh rocket, the first launch of their Simorgh rocket, which for comparison is somewhere in between like a Redstone rocket and a Jupiter rocket. And they were expressly told by the United States, do not launch that rocket. And they pretty much said, screw you anyway. And they've still been working on their human spaceflight program. And I am predicting that on Ramadan next year, we are going to see probably an uncrewed test flight of their one-person capsule to begin their human spaceflight program. And I just think it's so cool. Even though I don't have any vested interest in them, I think it's cool that they are trying their hardest to be part of that very exclusive club of human spaceflight capable nations.
All right. So one thing I'm going to do at the end of the year that I prepped no one for. By the way, you had asked what about Dutta. I do want to get to Dutta, but I think we should do that in After Dark because he has a really crappy camera.
Okay.
So, but I do want to get his answers is to his stuff. So I'm going to do this, and I'm going to do it to Dutta too. But everything I'm doing to Dutta is in After Dark. And here's the thing I didn't prep any of you for. Ready? We're going to start with you, Carrie Ann.
Great.
Moon or Mars first?
I hate you. Moon or Mars first?
Yeah.
So we're doing it for ourselves now.
Oh, yes, we are.
Fine.
This is amazing. I'm going to ruin everybody else's answer and say both. Next.
Jared?
Moon or Mars first?
Yep.
Space.
Space.
Space first.
Explain.
The destination doesn't matter.
Okay.
Go.
Okay,
Nice.
that's good. Tim
Go.
Dodd, the Everyday Astronaut. Moon or Mars first?
I may have. This year might be the year that I switch to Team Moon.
Oh, yes! Moon first! We got him! And then...
Maybe. Very apprehensively.
Space Mike. Moon or Mars first?
I still think we should go asteroid first, but I'm definitely supportive of Moon first. And if we can stay and get the architecture, it'll be so much easier to actually go to Mars afterwards.
Carrie Ann, would you go?
Ben, Moon or Mars first?
Oh. Well played.
Thanks.
I've been Moon first for quite a while. Yep. So I do like your answer, though, and I may have to start changing it. I don't. The destination truly does not matter. It is the journey, and so more so than both of them, I would argue all of them. Why stop at Moon and Mars? Continue on, do Enceladus. Go beyond our own solar system. Do all the things.
Yeah.
So
Absolutely.
Moon or Mars first? The answer is yes. And what else? And what else? And what else? That's where we should be going. But you can't do all of them all at the same time.
No, unfortunately.
You really
Not
truly
yet.
can't. So I think it's going to be cislunar space first, then the Moon, then kind of an in-between Moon-Mars architecture, then Mars, and then we're going to see branching out to other areas like Enceladus and whatnot.
Yeah.
I think that's how it's going to play out. Carrie Ann, would you go?
Do I get a Valium on the way up?
Absolutely.
Then yes.
Yeah, we'll knock you out if you want.
Perfect. Just call me Mr. T. Yeah.
I pity the fool.
Yeah, I don't know. So I'm old, and that's a really old reference to an old TV show you may or may not have heard of called The A-Team.
People know who Mr. T is.
You'd be surprised.
You would be surprised.
I think if I can get over the fear of the journey itself,
Yep.
yes, I would go.
But there's a certain altitude where you no longer care. Like once you get into weightlessness,
Yeah.
because you're no longer high up. Now you're just like up. Right? I mean, there's no up or down anymore, right?
Yep, we'll go with that. Absolutely. Here's the deal. I'm not letting you go without me, and I'm not going without you. So
All right.
once you're dead, the whole thing changes.
I've committed our friend Jeff. I've committed our friend Jeff to 10 free tickets.
Our
So-
good personal friend.
A good personal
Jeff.
friend
Yeah.
Jeff. We call him Jeff.
Yeah. We're on a first name basis.
First name basis.
Yeah.
So.
Jared, would you go?
Hell yes. And I'm probably going to have a Valium because I'm just going to be too amped up for it.
You're gonna have the wiggles the
I'm gonna
entire
be
time.
Like, yeah, here we go. I'm gonna be like, in the they're gonna like have the restraints on me. I'm like, yeah, here we go.
We're not moving yet, Jerry.
Because
I'm gonna help it go.
I get like super jazzed and amped up just getting on a plane. And like, can
Oh
you
my
imagine
God.
me getting in a rocket? Like, oh my God.
Oh my God.
I'm like a 5-year-old on a plane.
You're right.
You know?
I'm sorry.
Wow,
He needs
look
the
at that.
Valium. Never mind.
So, holy smokes, it's amazing. So,
You're going to hold the launch because they're violating vibration constraints.
Tim Dodd, the Everyday Astronaut, would you go?
Well, that's funny you ask, because believe it or not, I didn't tell you guys this, but I'm already in space.
Oh, so that's really like MTV crappy like camera things going on.
Totally not.
Oh, it's amazing.
I will be like the ultimate space tourist, but I don't want to go when it's like if there's any work to be done. Like, put me up there when it's like a cruise ship,
Yeah.
and I just go and eat pizza and watch a movie and then look out a window.
You want the indoor plumbing to be done.
Yeah, it's a hotel destination.
Yeah.
For sure.
No camping
and then
for
I'll
you.
totally go. But I do want, if we're going to the moon, I do want there to be a big giant dome where I can put wings on and fly around. A pressurized dome.
Yes.
That is like a dream of mine.
Well, I mean,
Yeah.
you'll have. There is gravity on the moon, Tim Dot, the everyday astronaut, so you'll be able to
1/6
bounce
though,
around.
so no, because if you have big, huge, giant wings, you can actually produce enough thrust like a bird. You can be a little birdie.
All right.
Inside of a dome with the
I believe the quote of the show is "You could be a little birdie."
He just wants to be a giraffe astronaut. Everybody knows
A
it.
giraffe astronaut. All right. Space Mike, would you go?
Oh, absolutely. Abso-freaking-lutely. And I do want to be put to work. I want to go on a spacewalk and, tighten some nuts and bolts and stuff. And I would love to go. I want to be a freaking space trash collector. I want to go out there and collect space debris and I want to go, and I want to live forever too, so that I can go to all the places. I want to go to the moon. I want to go to Mars. I want to go to the space station. I want to go to the Deep Space Gateway and whatever other future space stations and space colonies come out in the future. I want to do all the things.
So, Space Mike, do I need to change your banner to Space Mike, Space Janitor? Is that the new? No?
Maybe. I'm okay with that.
Carrie Ann, when do you think humans will first land on Mars?
So
Ben,
you're going?
Ben,
So
would you go?
Would you
dang
go?
it. We're
We're not letting you get out of this. This is,
Would I go? Yeah, no, I forget that. Oh, hey.
you forget that you're running the show
that I'm
and then
running
you don't
the
think
show.
that you have to answer the questions.
Yeah,
It's
would
okay.
I would go in a heartbeat. I'm a little bit with Tim Dodd, the everyday astronaut, on this one, in that I'm not sure I want to. Like, Mars, maybe not so much, because when you go to Mars, you're committing to a very long time. You're committing years of your life to Mars. To the moon, I'm committing a week, right? So 3 days there, 3 days back, maybe 2 weeks. 3 days there, 3 days back, a little bit of time on the moon. It's a destination kind of thing.
Right.
Yeah, I would definitely do that. Same thing with like Space Station or Deep Space Gateway. As long as I can come back, I do like the oceans. I do enjoy gravity. I would enjoy to experience microgravity, but I want to like experience it for a bit and then not have my spine expand painfully. So yeah, I don't think I want to go to, as mentioned in the chat room, back to glamping with tomorrow.
Yeah.
kind of, right?
Stop glamping.
Yeah, that's kind of what I want, though. That's what I want. So I would go.
So when Disney is going to space, that's when you'll go?
That's when I'll go.
Okay,
Actually,
perfect.
the Blue Origin ride, if you look at their YouTube channel, they have, as Space Mike mentioned in the news, they have the full mannequin Skywalker, the full ascent going up and all the way back down. That looks delightful. I would love to do that.
So
it
smooth.
looks amazing. I highly recommend you check it out. / Dear Blue Origin, how much are your tickets? Seriously.
Tell us already.
Well, I want to know what I need to save up to go to space, because this looks exciting and awesome.
What if it ends up being super cheap? Like, what if it ends up being like $10,000?
Oh, done and done and done.
I mean,
oh, done and done and done and
I
done
mean,
and
they
done
would
and
be
done and
booked
done.
up
Oh yeah.
forever.
Oh yeah. All right, cool. So there. All right. So Carrie Ann, when do you think humans will first land on Mars?
First land on Mars.
First.
Dude.
It can be flags and footprints. It doesn't need to be anything.
Oh man, I hesitate to hazard a guess because I am just going to ridiculously be so wrong, right? Like,
Sure.
I will be ridiculously optimistic and say by the end of 2021.
All right. Jared?
2045.
2045. Any particular reason?
Because you can't fool nature and physics. So,
Okay, that's fair.
Yeah.
Tim Dodd, the everyday astronaut?
By December 31st, 2029.
2029. Okay. And
By
Space Mike?
then,
By then, yep. Okay. Before 2030.
Yep.
I'm thinking that the first humans setting foot on Mars is going to be somewhere between 2045 and 2050.
Okay.
As long as we haven't all killed each other by then.
And somewhat fair.
Yeah,
all
it
right.
is.
I'm going to say, answering my own question because I remember this
Can
time.
I just say how much anxiety that some of these Twitter wars between our current president and
I
some
know.
other presidents of other nations have given me?
That is an after dark conversation, but yeah. All right, I'm going to say probably. I'm going to be optimistic as well, but I'm going to say 2028 because I believe that's when that because there are windows in which you can go, and I believe 2028 is an available window.
It is.
So I think that's when we'll. I'm not sure that's when we're going to have the first colonies, but I think that might be when we get flags and footprints. It's going to be very long, lots of footprints because they're going to have to be there for a while. But yeah, that's what I'm thinking. All right.
Yeah, the Apollo 11 of Mars. Yep.
Same question, but when do you think humans will set foot on the moon again? These are hard, I know.
Yeah, I think I put both of them kind of like in the next 5 years.
Okay.
Just because I can, and I don't mind being wrong, and I don't mind being wildly wrong, and I'm not going to hazard a more sustainable answer than that. Like, I would rather just be like, oh yeah, geez, I guess we missed it. Darn. Like, I'm not putting a horse in that game.
All right, Jared?
I'm going to say for the moon, 2030.
2030.
In there, yeah.
Okay. Mm-hmm. Tim Dodd, the Everyday Astronaut?
I think by 2025.
2025? Space Mike?
Honestly, yes. I kind of agree. Somewhere between 2025 and 2030. I think that'll happen.
I'm kind of in the same camp.
It's probably, and also I got to say too, it probably isn't going to be NASA, the Americans. It's probably going to be a Chinese, Russo-Chinese partnership that's probably going to set foot on the moon before we do.
Could be.
Yeah.
Yep. I'm thinking something like 2024, 2026. I don't think there's going to be a huge gap between the moon and Mars because I think the same core technologies are used for both. Certainly, entry, descent, landing technology needs to be slightly different.
Slightly?
Well, does it? I mean, if you're doing propulsive landing, yeah, you're going to argue atmosphere. But if you're doing propulsive landing, it's just heat shields at that point. So it's if you can propulsively land the same vehicle on Earth and on the moon, then you got Mars because they're right in between. So you're done. Yeah, you do. Okay, so why not?
No.
So I can deal with the atmosphere, and I can deal with landing in a microgravity environment. So I already have the heat shielding for the atmosphere, for way more atmosphere. I already have the propulsive landing necessary to deal with even less gravity.
More gravity.
It's that Mars has so little atmosphere. That's the big problem.
But it's irrelevant if I can already use the same vehicle on both options.
But you can't use the same vehicle on Earth that you can on Mars to land there. So if you look at the
but you will be able to. That's my point.
Oh, okay. I'm sorry.
Yeah, if you
never
have a
mind.
vehicle that
No.
I didn't realize we were talking about
land on Mars.
Yeah, I didn't realize we were talking about like some theoretical vehicle that is designed. Or some that's currently planned, if you will. So
yeah, I need to
dance around that.
Okay,
a little
I need
bit,
to tread lightly here, but I mean that has been publicly announced, right?
Yes.
And they have shown videos of it landing on Earth and landing on Mars. One could assume it can land on the moon. That's one vehicle.
Fair enough.
If you can do those two things, Mars is in the middle.
Yes,
I realize I'm oversimplifying.
I messed up on that a bit. So
Okay.
The oversimplification, I will beat you to a pulp on, but
it is still possible.
But it is with something that big, yes.
And I think I think you're getting stuck in all the JPL, like it's really blah blah blah. I don't.
No, it's hard.
It is hard, and they're the only ones who've ever done it, so I can't really discount them on that because literally the only humans in the history of our planet that have ever done this. So I can't be like, you're wrong. But they haven't ever tried anything quite like this either. So I am of the opinion, maybe mistakenly, that if you can do those two objects, while still difficult, that puts Mars in your sights.
As long as you have the delta V to handle
absolutely.
You should be able to do, as long as you have that energy to give out, you should be able to do it with the same vehicle. No one's ever done it before, and I guess that's the cool part about it. So
I was just answering Moon again. Okay, so last question, and then we'll wrap up this segment. Carrie Ann, why space?
Because you made me.
That's true. That is a true answer.
Oh, thank you for being here, Carrie.
I told you I'm funny. So my on all different social media, they're like, tell us about yourself, and they want you to have a little personal tagline, et cetera, et cetera. And I actually put something on my Twitter bio a long time ago and kind of forgot about it until you were about to. Until I finally realized you were going to ask this question. And what I have as my Twitter bio is, I fell in love with space when I saw the excitement in your eyes. And
the internet just collectively went, "Aww."
I wasn't talking about him. It's fine. But right. But the
I
truth.
hate you all.
The truth of the matter is I cannot remember a time that I have encountered so many different people from so many different walks of life, from so many different areas of expertise, of varying ages and backgrounds and ethnicities, et cetera, so on and so forth, that are all so excited about the same thing in different but still a very similar way. You can meet sports fans and they're all like against each other because my team is better than your team, and you meet even like Disney fans even are like, well, this park is better than that park, and that's generally speaking, slightly broad strokes. That's not the way space fans are. It's more just like, what's your interest? Cool, I know nothing about that. Tell me more about that because you're interested, or because I'm interested in what you're interested in, and it's still a similar kind of thing. And so there's something to be said about people who are space fans, I guess, that it's a very much so all ships rise with the tide kind of collective feeling, and it's hard not to get attracted to that or swept up in that, and it's fascinating. The stuff, I know nothing of planetary science, nothing. If you've watched the show more than once, I know nothing of planetary science. But Jared comes up with these really remarkable things that I've never heard of before, and it's really interesting. And you're a fantastic presenter as well, and so that helps.
Thank you.
Because some of the most amazing things talk about in the most boring way can still be boring, but it's really, really fascinating. And as much as I love seeing all the rockets and stuff, and Mike always schools me on what's going on and why it's different and
how many bolts a rocket has.
Right, right.
He knows it though. He knows it.
I know, and it's ridiculously, that's so impressive, and how you don't get, for lack of a better term, jazzed by somebody else's excitement and enthusiasm and love for these sorts of things, then I don't know, you must be dead inside, I guess. Yeah, I mean, there's a interesting connection. Smokey Dirg actually in the chat room puts it lovely. We are star stuff. We're just trying to go home, and there. So that's why.
Jared, why space?
Good answer.
Thank you.
Why space? It's because space challenges us to be the best that we can be. And that's the most critical thing to me in terms of the engineering that we have to do behind it, the operational aspect of everything, thinking of everything that you have to contend with on a flight, what we actually end up doing, collaborating internationally as well to accomplish mutual goals. We might have completely different cultures, but if we start talking about space, it's something that we all can understand. And it's something that working up at Griffith has really drove it home to me. Because when I'm up at Griffith working, I'll hear 10 to 15 different languages every single day. Space is not exclusive to a certain set of people because they have this certain correct amount of variables to make that happen. Space is for everybody, and when everybody participates in it, it brings out the best in us. And that is so critical, because there's very few things that bring out the best in us that also move us forward at the same time. And to me, space is one of those things. And it's so important that we actually do it, because Earth isn't going to be here forever. So we got to find somewhere else, be it whether natural or man-made, due to whatever causes the Earth to eventually become uninhabitable to humans, at least. So we gotta go, and it does it, and it brings out the best in us when we do. So
to go to that point, there was a friend of mine recently. I make coffee for a living. That's what I do. I do this on the side. This is fun. This is my hobby, right? But I happen to work in an area that works towards space things and spacefaring things. And somebody said, maybe you don't understand your value. That's the honor of working here. Every job is towards perpetuating the mission of colonizing the universe. And I was like, thank you. Mike was talking about being a space janitor. You're right. It's anybody can get involved. Anybody can participate. Anybody can support. And it's
and every position involved in that too has the value of moving that forward.
There's value in that, yeah, absolutely.
So, yeah.
Tim Dodd, the everyday astronaut. Why space?
Yeah. Well, I say this all the time, but it's kind of that same sentiment that space is literally for everybody. And my favorite way to summarize this is with 1975 Apollo-Soyuz mission, bringing two literal enemies together, uniting in space, sharing handshakes, drinks, dinner, hugs. To me, that's why space. Because at the end of the day, when it all comes down to it, you realize we are all on the same home. We're all under the same roof here, and we're all on the same team. And it's the one thing that literally, physically, besides our biology and besides who we are as people, it literally does unify us. And I think it'll become more and more obvious the more and more we explore. So the further we get away from Earth as humans, and the more collectively we do so, the more and more it will unite us as a species. So, yeah, I think that's why space.
Space Mike, why space?
I mean, you guys have taken the words out of my mouth. The only thing that I can really add to what you guys have said, because I completely agree with everything that everyone's been saying so far, is that, space and that international cooperation, and that the fact that you can have people who normally would be hated enemies cooperating and sharing that passion and excitement about space is, I feel like, our species' redeeming quality. It brings out those best qualities out of humanity. I mean, we gotta admit, we're essentially Neanderthals with nukes here. And to be able to bring out that excitement and empathy and willingness to cooperate and move forward as a species is just, that transcends any other type of thing that has that type of goal, like religion or something like that. Space is moving humanity forward, and I think that it is absolutely necessary for our survival. Space and moving forward in space is the most important thing that we are doing right now, and the importance of it and just the awesomeness of it just overwhelms me every time.
All right, thank you, Space Mike. I'll answer my own question. Go over here, yeah. So Ben, why space?
I guess you didn't like that answer.
Why space, Ben?
No, I like. Yeah. So, life likely came from the stars. The building blocks for everything we know here on Earth likely did not start here on Earth. It started out in the cosmos, and it got flung to Earth over billions of miles and light years of travel. And it's incredible that we have life here at all. And it's even more incredible that we have intelligent life. And even above and beyond that is our capability of then going back out there to see where we came from. So certainly life started and formed here on Earth, but it started from all these different elements throughout the solar system, throughout the universe. And that creates a natural desire and wonderment to figure out where we come from. And to answer those questions, we're going to have to go out to the stars. More than just our own local solar system, we're going to have to go all the way out to nearby solar systems and stars and whatnot. And we are on the cusp of being able to just explore our own solar system. It is exciting. It is dynamic. It is scary. It is all of the emotions wrapped into one. People will do incredible things. We will learn awesome stuff from doing this. Awesome science. We will bring back with us incredible technology. There will be horrible things that happen because of this, because the universe does what nature likes fighting back, and there will be bad things that happen. But as everyone around this table has essentially said, it will be humanity at its finest. And there's something great about being a part of humanity at its finest. And that's why space, because it is us at our finest, exploring, figuring out where we came from, figuring out the ultimate questions like why we are here and who are we. That's why space for me. Also because it's super fun.
Yeah.
All right, that is our show. Any final comments before I take us into comments? No? I think it was a great segment.
Yeah.
Thank you, everyone. Thank you for letting me throw that curveball. Now, if you want to see Dada's answer to all of those questions, I'm going to make him answer everything in After Dark as well, which he's slightly cringing on.
But it's had like 3 hours to think about it now.
So I hope he better have the best answers of all of us. No pressure, Dada. All right, we're going to take a quick break. When we come back, comments from last week's show.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, through the heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
The last show of 2017 continues. Now, before we get into our comments from last week's show, a shout out to everyone who have helped contribute to this one. This is our Escape Velocity citizens. These are people who have contributed $10 or more to the specific episode. We also have our Orbital citizens, people who have contributed $5 or more to this specific episode, and our Suborbital citizens, people who have contributed $2.50 or more to this specific episode. To find out how you can help crowdfund the shows of tomorrow, head on over to tmro.tv. All right, let's get started. This has been a somewhat long show, so Carrie Ann, we're going to breeze through these somewhat quickly. What was last week's?
Last week's show dedicated to our late director, one caffeinated, was all talking about webcasting launches and social space.
Somewhat an apt show, actually. Also, and I know we're going long, but it's the last show, we can. The community had a brilliant idea in last week's show. We had never come up with a name for the planet that is behind us. It is just a randomized, non-real planet.
Technical designation, but not a real
planet.
Yeah,
we called it Planet. This one was Planet Y, I believe is what we called it.
Yeah.
But we have, in honor of Adam, his screen name was Caffeinated, so we're naming the planet Calf. And on this camera, where there's just like black behind me. We always had intended of putting stars up there. So what we're working on is getting the molecular structure of caffeine in a star formation that will be back up on that wall. It will be somewhat hard to tell on camera, but it's more the thought behind it. So kind of in memory to Calf. He will be forever remembered by the entire back end of the set. That's kind of our memory to Calf.
Which is kind of where he was for most of the time.
Right? Yeah, exactly. It seems really apt. I think it was a great, and this was all the community that came up with it. I thought it was brilliant, and I thought it was very touching. Absolutely. So Planet Calf, and then we'll have the constellation caffeine. Behind him, or orbiting the star 8NED. I don't know.
I'll get that for you.
Thanks. That's great.
Thank you.
All right. First up, Capcom.
Comes off of Reddit. This is from one Brandon Mark. I have to note that there's a chance tomorrow, 12/12, or December 12th, we'll see an Arian, Electron, Falcon 9, and New Shepard launch all in one day. Welcome to the future.
So it wasn't all of them all in one day, but
which is a little unfortunate, but still.
2 out of 4 ain't bad.
2 out of 4 is not bad, and we've got, if you checked out that last calendar, we also have 2 launches in the same day again, minutes apart from each other. So that's going to be absolutely
exciting.
It's going to be fun.
Different areas of the planet just boom. launches, it's going to be incredible.
Actually, one's going polar and the other's going equatorial, so more like,
gonna-
and the same ocean as well, other
Yeah.
sides of the ocean. Woo!
How are they going again?
Woo! Like that. So can't wait.
Yeah, that's going to be
So,
pretty cool. It is the future, right? And that's part of what made 2017 so incredible was
Yeah.
just the launch cadence. And, there's so much stuff going on right now. All new industries opening up, so many more launches and so many more launchers. All right, next up.
Next up, also from Reddit, from Dansoton?
Dansoton.
I understand that Ben Credible has to be very careful about not speaking about confidential or even ITAR/ear matters. However, I thought there was so much more that could have been discussed relating to how launches are webcast in general.
Yeah, obviously I'll take that one. I don't really do that because I don't feel like that's interesting to the community as a whole. I feel like everyone's more interested in the rockets and the science behind that and the planets and everything that's going on there, as opposed to how a certain camera is working with launches. After reading the comment, I don't necessarily disagree because when I kind of separate myself from it, there is some interesting stuff in like how you deal with rocket fire on a camera. That's somewhat hard. How you deal with rocket audio. That's really difficult as well.
Well, there's also a lot that we didn't focus on as well. Things like how do you effectively communicate some information to a new viewer of what the next step is supposed to be? What's the next thing going to happen? How long do you have to wait for? There's a lot of things like that we didn't even delve into that we probably very easily could have. So it is a little unfortunate that we didn't do a lot of those things. But at the same time, much like this show has been, you don't want Ben to talk for the entire episode. So there's also that.
Yeah, you don't want me to get
Wait,
into
there's
that.
smoke coming out. Is that supposed to happen?
Yeah.
I will say it's a balancing act on my side because there is ITAR, which is and EAR, which are, without going into what exactly the acronyms are, they're U.S. laws that prevent us from talking about a good chunk of rocketry. The idea. I disagree with them, but whether I agree or disagree is completely irrelevant. They're still the law, and I must follow them. So the idea is we don't want to get this technology, which can be used to send very nasty weapons anywhere in the world. That technology shouldn't go into the hands of people who would use it nefariously. So I understand the sentiment behind it. It's just that, then they'll just go to Russia. It doesn't.
Right.
Anyhow.
Yeah.
My feelings on it are irrelevant. It's still the law. I must follow it. So some of this does fall under those laws. Additionally, I do have a conflict of interest. We always refer to as Company X. I do work at Company X, which is an aerospace company that does have launches, that does launch things to space, and as such, I have to be very careful because we don't want you thinking that I'm speaking on behalf of Company X. I am not. We also don't want other people from Company X to look at this show and go, well, he can talk about the company, why can't I? They cannot, neither can I. So that's why we bring on Space Mike and Tim Dodd and Jared, so they can speak to those things because I simply can't. And there have been a lot of comments recently as to, well, I realize you've got some of this stuff, but can't you talk a little bit about it? The answer is no, I really can't even talk a little bit about it. I cannot talk at all about Company X because there's optics that go around that. That won't change anytime soon. So that's the cold, harsh reality of it. But just because I can't talk about it, Carrie Ann can't talk about it, doesn't mean that Jared and Space Mike and Tim Dodd, the everyday astronaut, can't talk about it. The thing that also sucks is not only can we not talk about it with you, we can't talk about it with them either. So
welcome to aerospace.
Yeah.
Go ahead, Mike.
And the way that I see it, like whenever you guys do talk about this stuff, like as much as we would love to know that insider information, even like between private conversations, we don't want to ruin what you guys have going on. And just, it blows my mind that you are doing what you're doing. I mean, even you, Carrie Ann, I mean, the support that you are giving to that, I mean, you literally are enabling all the people that are building those rockets to actually do some work. So you have a big role there too. So I'm just, and for you guys too, let's not. I don't want to ruin what's going on for Ben and Carrie Ann. So.
And that's exactly it. We don't want to. We don't want to destroy the greatness that we have. And so rather than poke the bear, we just don't. We simply choose to not talk about it. We don't want to give you any information, nothing at all. Like with Space Mike, when you're doing your thing, we usually go full screen to you, so you can't even read emotion on my face or Carrie Ann's face, right? So no pointers, no nothing. That's just how it is. I'm sorry that that's the way it is, but for now, that will not be changing. I don't foresee that changing, and I do think it's fair, and it does actually make sense. I wish I could talk about it, but I understand why I can't, and I hope you do too. Okay, next up.
Next up actually comes off of YouTube from a Dave Martin, perfect. It's, it's all the space things. I remember the first launch webcast I watched was the first time SpaceX re-landed a rocket. Everyone at SpaceX was losing their minds, and I was at home by myself losing my mind as well. Jared mentioned shared experience. I was alone, but I felt like I was sharing it with all the SpaceX people, and it was so exciting. I wish there was more of that, to be honest. More epic launches, please.
Yeah, I mean, we'll turn
I
it
think
to...
every launch is an epic launch.
Yeah, from every provider.
Right?
But
Like,
I mean, I'll turn it to you guys. You guys have... Space Mike, you've seen a launch in person, right?
I've only seen one launch in person, and that was the very last space shuttle launch.
Okay. So, but I mean, there's still a moment there. There's still an excitement. I mean, right? There's...
Oh, yeah. I mean, you cannot really describe that. Just like we were talking about earlier. I mean, feeling those vibrations and seeing it with your own eyes it's almost like a spiritual experience. I mean, it's just it's incredible. And yeah, I feel like everyone who, especially people who do get excited about space and who get really passionate about everything that's going on, you gotta see a rocket launch at least once in your life to just experience that, because it is a life experience.
Yeah, and my friends will always ask me, what's a rocket launch like? And I'll be like, when can I get you in the Jeep and take you up to Vandenberg?
Right,
because
we'll just go.
I can't tell you. You have to come along with me and see it, because I just can't explain it to you. I mean, I've been to 17 launches, and I just still can't get enough.
It is an emotional experience.
Yeah.
It's truly awe-inspiring in the sense of it creates awe.
My favorite part of a launch is when the sound starts rolling in, and you can always tell that people are very excited about that because they get very loud, they start cheering, they're clapping, and then there's like this moment when it just like kicks in, and people just like stop, and they just go, and they watch it, and they experience it, because there's something about that overwhelming power that's on display. And you're realizing that this power is being controlled with the utmost precision. Like that's a tremendous amount of power, and that's putting something to within feet of where it needs to be, or excuse me, meters of where it needs to be. So like, just ridiculous.
Go metric.
It's ridiculous. So yeah.
Next up.
Yes. Next up comes off of YouTube from Destructor1701. Why is social space important? Because it's part of the puzzle. By virtue of being, as Jared says, edge of the envelope engineering, it's really difficult to say, space launch is an enlightening thing to watch. It's in-your-face science and it's engineering. It's very, very visible illustration of the scale of reality and the mechanics of the universe. People who've never thought about space before cannot help but learn cool STEM facts by watching launches.
STEM being science, technology, engineering, and math. Although sometimes STEAM, we add art in there.
Yep.
Very important as well. So.
I'll toss that actually to Space Mike first. Your thoughts of using launches to push people into STEAM.
And it's funny. Carrie Ann was just praising earlier, and I really appreciate what you said about how I know all this and memorized of a lot of kind of almost boring information and nitty-gritty nuts and bolts type of stuff. And yet, with just about every webcast that I watch, especially the longer ones that are longer than the minute-and-a-half Chinese launches, I usually learn something new every time. And I've been studying this stuff like super seriously for almost 10 years now, and I'm still learning new things all the time. So I absolutely agree with that, and especially for someone who isn't, initiated into all of this type of stuff, there's so much that you can learn and just have your mind blown just watching any webcast. Pick one, and you can learn a lot.
Yeah, totally.
Jared?
Yeah. I mean, it kind of stole my thunder because it was exactly what I said in that comment. So, but yeah, it's so important to be able to reach out to people, especially people who have no understanding of how rocketry or spaceflight actually works, and have something there to very easily explain it to them. Even though it's very challenging to easily explain these things to people, it's possible. And when you do, the light bulb often comes on and they get hooked, and that is a great way to get people into enabling STEAM, which is very important. So,
final comment.
Yeah.
Final comment of Orbit 10. This is the last one.
Mm-hmm.
Oh boy! Yeah, watch me not be able to read it. Then this one comes from comes off of Facebook from one John Benstead. Says, doing webcasts of launches could be used to market Tomorrow. Be sure to have the Tomorrow label and let news outlets use it for free.
Mm-hmm. I think that's an interesting idea. Kind of expanding Tomorrow into something bigger than it is now. And looking towards Orbit 11 for space, we are going to, in the very early parts of 2018, be bringing on Tomorrow Science. I'm very excited about that. We've got an incredible group of people that will be doing that. And then we're also in talks to start Tomorrow Tech, and then a potential rebirth of Tomorrow Cities in the form of Tomorrow Transit. So all three of these shows are in work. Science is the furthest along at this point. I'm hoping for a very early Q1 deployment of Science, but we will see. I'm even more aggressive on my internal timelines on that. But yeah, I'm hoping to expand it to something, as we've been talking a little bit in the show, above and beyond just what we're doing right now, as a way to get people excited and going to space. And I think the low-hanging fruit is talking to people who are already interested in science and reminding them, space is our next journey out there, and there's incredible science to be learned out there. Not that they don't already know that, but really pull them into the space community. Tech, I think, is another low-hanging fruit. Tech nerds, you can really easily reach them and go look, you'll understand this, and getting as many people as we can excited about exploring the cosmos. All right, that is our show for 2017. Those are all of our shows for 2017.
Wrap up this Orbit
10 is done. That was a big deal for us because it was a massive change. Yeah, go ahead.
As you said earlier, 41 shows.
41 shows
was the previous record, and then the capacitor said 46 episodes, 4 people on camera. 46 minus 4 is 42, which is the meaning of life confirmed.
Boom!
Confirmed. Confirmed.
Confirmed.
We're doing something right.
It is not the meaning of life. It is the ultimate answer to the life universe and everything to be fair.
That's true.
We did it, everyone! Yay! And here's the other confusing thing. Mini Stoge says 10 years. So Orbit 10 is actually 9 years, right? Because you start with we didn't start with Orbit 0. We started with Orbit 1, essentially. Technically, 10 years will be March in Orbit 11. So we're coming up on 10 years. It's going to be, I'm very excited for that.
Yeah.
It has been a lot of fun. We've done a lot of great things. We did a lot of not so great things, but we're learning along with you and trying to improve every single time. And part of the people who have helped us to improve every single time would be our ground support citizens. These are people who've contributed between 1 penny and $2.49. To that, and in addition to getting all of Dada's answers, I'm going to be talking more about Patreon in After Dark, and we're going to be talking about some of the options I see moving forward. And to find out how you can help crowdfund the shows tomorrow, head on over to tmro.tv. And I look forward to speaking to everyone in 2018. See you next year.